This homework, hopefully you're looking at, is 11.7 strategies for testing. Is that what you're looking at, guys?
Yeah.
Okay. Now, the reason why this is 0 points is that I want you to do as many questions as you feel comfortable about, and there is no consequence to getting them wrong. So it won't affect your grade because it's 0 out of 0. So in a way, you're getting 100% or you're not, but it doesn't matter. The main reason I want it to be there is that up to this point, every test that we've done has been in a section. So you kind of knew what the test was going to be. In other words, you knew it was going to be alternating series because that entire section was all about alternating series, or you knew it was going to be the integral test, or at least you knew it was either the ratio or the root test. What we're going to do now is show you a series, and that's what this is. And your job is basically to figure out what would be the correct test. Because convergent or divergent, you can always guess those ones. So I'm not wanting you to get too caught up on, doing it. So let's look at examples here. When you have a series, there's very often one test that's going to be the easiest to do. Sometimes you'll find a series where there might be 2 or 3 different tests that would all work, but one of them's kind of better because it's less work. So we have a list of tests in no particular order. We have the divergence test, the P-series test, the geometric series test, alternating series, comparison test, limit comparison test, integral test, telescoping series, ratio test, and root test. I think I got them all. So let's make that even bigger. Don't need the details, just need to know what test would you use in question A? Because this is the kind of thing that might happen in your midterm. I won't tell you to do a particular test. I will just say, here's a test, prove it converges or diverges, and I need to see the working. So you need to have a test, right? You need to know which one of that list would be the best one to do. Any suggestions for 1A?
You could do 6 to the negative n and do the root test, probably.
Oh, interesting. You could. And do you want the bad news now or the good news?
Yes.
Yes, okay. You could simply just leave it alone, right? And do the ratio test. And it would work. And you could do a geometric series test because the R value is a 6. Now, out of those two, the geometric series test was quicker. So that's the bad news. You could have done it quicker, right? But it would still work. Now, question B looks very similar to it, but how would you approach that one? And there's at least 2 tests, but there's one I would use that's less work.
Is limit comparison test applicable?
I would do just a comparison test. And it behaves like A. So if that's convergent, which it is, a comparison test will make that one work. Now, these two, I think, are candidates for, and I'll tell you what test and why I would do it. So I'm going to give you some experience, my experience. When I look at this guy here, I see a U sub, I see an integral test. Right. So I would do an integral test. In this one here, can you see that little power of n guy? What test works really well with an ugly guy to the power of n?
And the root test.
Yeah. Now, if I was doing this one, I could certainly do a comparison test. I could also do a ratio test. I would probably go in this case with the ratio test, because that n there makes a difference, right? It just makes it harder to do it. And I would do a ratio test in both of those. I think this one's a no-brainer, but hopefully you can tell me. What would question 4's test be?
Alternating series.
And it's screaming out alternating. Would you agree that if you see one of these, there's a very good chance it's alternating? And you could say a ratio test as well, but alternating series test would be my go-to guy. That one, I don't know if you would see it or not. What test in question 5?
This looks familiar to the integral one.
It is the integral test. And you're going to do a U sub and it'll work. That one will take you forever, but that's the test I would use. Question 6, there's only one test that will work with question 6. Some of them you can do it 2 or even 3 ways, but not question 6. What test is question 6?
Ratio test.
Correct. What was this? What did that have that kind of made it the ratio test?
Everything, but
Well, not if, well, I guess
factorial.
the factorial. If you ever see a factorial, just go the ratio test. Don't go anywhere else. Trust me, it won't work. Right? Try and integrate a factorial and see how far you get. Right? It ain't going to work. Right? Ratio test it is. Now this weird, ugly guy. What test would you use for that one?
Comparison test.
Yeah, I'd compare it to something like 1 over 5 to the n. By the way, it converges. Can we just cut to the chase and say, yep, we're looking at another one of those alternating series tests? Would you agree another alternating series test? This is, I think, the only question where this is the test to do. All the others, I mean, you'll probably find 2 or 3 situations where you could use the other test, but I believe this is the only one where this test works. What's the test for that?
Integral.
Oh, God in Himmel, you're a brave man. You could, good luck. I would almost give you money to do it, just to see how much pain you would cause yourself. I do not want to integrate that. Trust me, I don't want anybody to integrate that. I'll give you a clue. We did this test in week 1.
Is it brute force, possibly?
Limit comparison test.
No, you're drifting. You're going somewhere else. Week 1. I know I like the brute force, but I wouldn't call it that. I think you're on the right tracks.
Divergent test.
It's called the divergence test. And in the divergence test, you do the brute force, right? And if you put that one in, I think you would find a result you probably wouldn't like. That horrible one you could do as a limit comparison test to 8/5 to the power of k. That one I think is an obvious one. There's only one test that would work with question 12.
Be the root test.
Be the root test. And you know, you're going to have, I think we did it right at the end of yesterday. Aren't you going to have to do that 1 + 1 over n thingy bob and get e to the -2? And yeah, messy. There's a much nicer one. Would you agree you could do that one using the root test? So how do I recognize root test? I recognize them because of the power of n squared or the power of n. If I'm looking for a ratio test question, if I can find it, if I see an n factorial, it's a ratio test, right? If I see a -1 to the power of somebody, wouldn't that be the feature that would make me go alternating series test, right? And then you've got comparison and limit comparison. Integral test. Well, if you're looking at an integral test, don't you want something that kind of looks like it would be a U sub? And there was an earlier one, I think, as well, wasn't there? Maybe there wasn't. Oh, yes, there was. Wouldn't that one work? And in that one there, the U sub would be the bottom. And then they finish with some questions that involve us watching a video and then doing some work. So that section that we've just talked about that has 0 points, you could do absolutely none of them and it will not affect your grade, or you could try, you know, half of them because you want practice. They're really kind of a place where you can do some questions, right? Kind of mix and match, because there will be questions in your midterm and your final where I will not be telling you which test to use. Half the questions I will. Half the questions I will say, use the integral test to test this guy, in which case you have to do it that way because I've told you that's what I want. Or use the ratio test. But there will be other questions where I won't tell you anything, in which case you might choose method 1 and someone else might choose method 2. And as long as they work, it's not wrong. But one of you might do it in 5 minutes and the other does it in 25 minutes. So, you know. So here's a little rule that's not in a book. Never do the integral test unless you can't find anything else that works, right? So the integral test should be the last test in the world that you ever try. You're going to have to look at it and say, could I do it this way? Nah, can I do it that way? No, okay, I'm stuck. It's integral test. But keep it to your last option. I like personally, I think the ratio test works out really well, and doesn't the root test work out really well? So if it's possible, I would try and use them in a situation if it's possible to use it. So here we're on to our last section. So we're going to do it this today. We're going to get it finished on Thursday. And it's power series. So let's tell you what a power series is. It's an infinite polynomial that is written using sigma notation. So let's give you an example of a power series. In no particular order, just how they come into my head. There is a power series. N equals 0 to infinity, x to the power of n. If you want to know what it looks like, it would be x to the 0 plus x1 plus x squared plus x cubed forever. And that guy there is 1. So you agree, isn't that an infinite polynomial? But it tends to be written using sigma notation because isn't that a very convenient way of writing? Now you might think that power series are not going to be very useful or interesting, because if you're adding up an infinite polynomial, doesn't that mean that if you try to sketch it, for instance, it would just be infinity, right? But that's not necessarily the case. There are some very interesting power series that are actually a reflection of a function that you know. For instance, you might not know, in fact, I'm pretty sure you don't, unless you've taken this class before, that power series is actually 1 over 1 minus x, provided you only use values of x in a certain range. So provided x is between 1 and -1. Now you might think, nah, I know what polynomials look like. Don't polynomials look like bumpy hills? And so an infinite polynomial would just be an infinite number of bumpy hills, right? Maybe going uphill, maybe going downhill, maybe sinusoidal, but they always have hills, don't they? They always bounce about. And I know what 1 minus x looks like. And 1 minus x doesn't look like a bumpy hill. It doesn't look anything like a polynomial, but nonetheless it is. So I'm going to prove to you that that guy is equal to this fellow. And this restriction here is important. This restriction is called the interval of convergence. So when you do a power series, there's always going to be an interval of convergence attached to it, which says this power series equals something that's not infinity, as long as you choose values of x between -2 and 2, or between 0 and 40, whatever it might be. There's always going to be an interval of convergence. So let me call this guy S. And I'm going to show you that S is equal to this fellow. So I'm going to take this and multiply it by x. So 1 times x gets me that, x squared gets me that, x cubed gets me that, x to the 4. And you know how I've written them slightly off-centered so that the x's and x squareds are all above each other? Do you recognize this? And don't both of them go on forever, right? Continuous. Now I'm going to take this guy and subtract this guy. Well, that ends up being, you take the top row and you subtract everything from the bottom row. But when you do that, don't you get the answer 1? Because all the x's and x squares get killed off by the guy above, right? Top thing, take away bottom thing. Now, if you pull out S as a common factor, you get that. And then if you divide both sides by that guy, have I convinced you that that power series is actually 1 over 1 minus x? So you got to get your mind around this concept that functions like this can be written as power series. Technically speaking, every function in the universe, right, sine x, e to the x plus 1 over the square root of x plus 2, right, anything at all, can actually be written as a power series. And when we make that observation, that all the functions that we've seen in our life are really can be written as power series, it gives you a lot more insight into what those functions are made from. In other words, you're looking at the skeleton of what makes a sine function the sine function, right? Because right now you just say it's sine x, right? It's up and down, up and down. But what is, what's it built from? Well, it's built from a power series. And we can then analyze what the power series looks like. I think that's kind of cool. So every function in the world can, at least theoretically, be written as a power series. And not today, but in the coming days, we'll even show you how to take a function like sine x or e to the x and create its power series. But what we're going to focus on today is finding the interval of convergence and a thing called the radius of convergence. They're very closely connected. And the radius of convergence is very often r equals, and it's a number. Now it's like r equals 0, r equals 1, r equals infinity. And essentially, the radius of convergence tells you how far from the center outwards do you go. So for instance, if the radius of convergence is infinity and you start at 0, that means it works for everybody, right? For any value of x you like, it works. Now, if the radius of convergence is 0, then that means that your power series is totally useless, because the only thing it works for is x equals 0, right? Because 0, either side of 0 is just the number 0. And everybody else is somewhere between those two extremes, right? Now, we're going to be focusing on finding radius of convergence, and then after that, interval of convergence. And the main guy that you're going to use is we're going to use the ratio test. Okay, let's take the guy that I've just done a moment ago. N equals 0 to infinity, x to the n, right? And I'm going to find the values of x that converges for, right? That's my goal. The values of x for what that converges for, right? So if x is a half, it works, because isn't that just a geometric series radius a half? So an is going to be x to the n. An plus 1 is going to be x to the n plus 1. Are we comfortable about an and an plus 1? Now, normally these would be numbers, but now they're going to be x's, right? We can handle that. Now, the ratio test says the limit as n tends to infinity of an plus 1 over an. So that's going to be the limit as n tends to infinity of x to the n plus 1 over x to the n. Do you notice that these two guys cancel out really well? What happens if you take this guy and cancel it with that guy? What is left?
X.
Just x. So far, so good? Now, according to the ratio test, oh, by the way, isn't this answer then just going to be the absolute value of x, because there's no n's in it? It's a bit like saying what's the limit as n tends to infinity of 42? The answer is just 42, right? Now, according to the ratio test, what must the limit be less than to converge?
1.
So we are looking for values of x where the absolute value of x is less than 1. Would you agree then that the interval of convergence would be -1 to 1? So as long as I choose values of x between -1 and 1, this guy over here will work. Now, who is the radius of convergence? Well, let me tell you who he is. He's dead easy. He's 1. So whenever you have absolute value of x less than, in this case, 1, the radius of convergence is 1. You're going to see later that that can change, but right now it's 1. And a lot of people, unfortunately, think, hey, that was an easy question. I'm done. Well, no. Because the interval of convergence, you need to check the endpoints. And the endpoints are what we call these two numbers. So we need to check for x equals -1, and we also need to check for x equals 1. Now, if you plug in x equals -1 into the original, and the series that you get converges, then that means you can use -1, and you'll put a square bracket around it to saying, not only is it from -1 to 1, but you can use -1. Right now, aren't I saying you can't use -1? So we have to test each of those. And in this one, it's going to be trivial. By that I mean, it's almost like duh, right? So here goes. if you take the power series and you replace the x with 1, you get that. Would you agree that adding up an infinite number of ones is bad news? It diverges. Does that make sense? Now, since it diverges, we can't use -1, right? If this had been something that converged, then I could use -1. And then you check out the other one, which is probably not going to be any better. And I'll make that +1 and this -1. So I now have -1 to the n. Can I tell you right now that that also diverges? Because isn't that 1, take away 1, add 1, take away 1, add 1, take away 1? If you did that, wouldn't it just bounce between 0 and 1 forever? So now that we're finished and checked the two endpoints, you can now say for sure that the interval convergence is all the values of x from -1 to 1, and the r value is always going to be, in this case, 1. It never changes. That's, believe it or not, one of the simplest ones that you're going to meet. So let's add to the mix and make your life difficult. This is a version of question 1. So we are going to find the radius of convergence r and the interval of convergence in this question. AN is basically all of this stuff. EN plus 1 is all of this stuff, but the n's are going to be replaced by n plus 1. Can I stop writing that from now on? Can we just assume that we know how to do AN plus 1? It will save a lot of writing for everyone. So the ratio test is the go-to test. So we figure out what that is. In this case, I don't have fractions, so it makes life a little bit easier. The n plus 1 guy goes on the top. And the n version of the guy goes in the bottom. That's pretty good. Let's do a whole lot of cancelling now. That 5 can cancel with that 5, agreed? Anything else here that you can cancel?
xn plus 1 over xn becomes just x.
Okay. Can I get rid of these two guys? Although strictly speaking, they do cancel and they leave a -1 behind. When you stick things inside absolute values, don't -1s get killed no matter how much there's there, right? So just kill the -1s off totally and don't worry about them, they're gone. So we're now left with the limit as n tends to infinity of n plus 1 over n and an x left over. And I'm just separating the two out. What does the limit as n tends to infinity of this guy become?
1.
1. Can you do it with a L'Hopital, whatever technique you prefer? And so we now know that it's 1 times absolute x. And guess what? We got the absolute x as the answer. So far, so good. Now, once you get the answer, whatever it is, for convergence, shouldn't it be less than 1? What is r, the radius of convergence in this question?
1.
1. Our initial interval of convergence, isn't it going to be all the values of x that have the property that their absolute value is less than 1. So it's going to be this range here. Now, I'm going to test the endpoints. Okay, here it goes. N equals 1 to infinity, 5, -1, n, -1 to the n. Well, that is going to be n equals 1 to infinity. Isn't -1 to the n times -1 to the n -1 to the 2n? Do you agree? Put that to the side. I'm saying that -1 to the n combined with that guy is -1 to the 2n. And I'm saying that that's always going to be 1. Are you comfortable with -1 to the power of 2n, 4n, 6n? It's going to be 1. So, don't worry about it. Isn't the answer just 5n? Does the series sigma 5n converge or diverge? And don't overthink this one.
Diverge.
Right, isn't it going to be 5 plus 10 plus 15 plus 20? Diverges. Which means I'm not going to be able to use -1. Now, if I try x equals 1, I get 5, -1 to the n times, I guess 1 to the n. But isn't 1 to the n just 1? So what I end up with, right, 1 to the power of n is just 1, is I end up with 5, -1 to the n, n. Now, if you did this one, wouldn't the answer be things like -5 plus 10, take away 15 plus 20, take away 25 plus 30? Wouldn't it be divergent again? Agreed? Divergent. Which means that that is the interval of convergence, and that is the radius of convergence. So let me see if I can pick one where the radius of convergence isn't 1, and where at least one of these two endpoints works, right? See if we can make that happen. So I'm going to have to look at a question and see what we get. I don't want that yet. That's suggesting, but I'll do that again. Yeah, this one will do. Oh, darn it, it only does one of the two. Oh, okay, this one will work. This is question 8, or a version of it at least. And we have n equals 1 to infinity, x to the n over n to the 4, 4 to the n. So the ratio test is the limit as n tends to infinity of an plus 1 over an. So this guy with n plus 1s, and then if you divide that guy, you basically turn the n1 upside down. We all happy about that's the first guy and that's the other guy turned upside down. Right. So this is an turned upside down. Right. This is an plus 1. Now there's an awful lot of really nice cancelling going on here. Anybody want to tell me something in the top cancelling something on the bottom?
Yes.
Go for it.
So the x to the n plus 1 cancels out with x to n, become x.
Oh, you're just lazy. You're picking the obvious one. Come on, give me a good one. There's one more you can do.
Yeah, the 4 to the n plus 1 on the bottom cancels out with 4 to the n, become 4 on the bottom.
Agreed. Stop there. That's all you can do. So I'm going to do the n to the 4 and the n plus 1 to the 4, and I'm putting them together. And if you look at this guy, all you've got left is essentially an x over 4. right? 1x, 1, 4. So the things that have got n and the things that don't have n, right? Now, this is a pretty ugly expression, but I bet you, well, I'm not a gambling person. Well, actually, I'm contradicting myself. If I was a gambling person, which I am, what value would I gamble that this is equal to?
1.
1. How would you prove it to me? Because it is 1, you're right.
Well, if you FOIL it out, it will have like a n to 4 if you divide 4 to both top and bottom and take the infinity to it, it will result to 1.
You nailed it, yeah. Or just do L'Hopital lots of times. Now, I don't expect you to do that every single homework question, because that's just busy work. But I do expect you to do it the one time you get it in the midterm, right? Because in the midterm, you're not just telling me the answer, you're proving to me it's the answer. You see, there's a little bit more, right? But as far as the homework goes, if you want to look at that and say, yeah, that's 1, I'm cool with that, right? But in a test situation, you're going to have to do what Viet said, FOIL it out and divide top and bottom by n-4 method. Or you could do the L'Hopital. I think you have to do L'Hopital 4 times, don't you, before it works, but it works. And you got your answer. Well, since that's 1 then, doesn't that mean that this thing ends up being that, right? That's what the limit is. And according to the ratio test, doesn't that need to be less than 1? And before you jump the gun and say, okay, R equals 1, I'm ready to go, don't. They always have to be done as an absolute value of x or x plus 1, right? This bit here is not allowed typically to have any numbers, right? So it has to be the absolute value of x, okay? Do you see how I would get from this line to this line is basically multiplying by positive 4, and as long as the numbers are positive, this is allowed. So I now have an R value that is not 1, yay, right? So radius of convergence could be 4. Now, if you want to solve that, it's -44, and let me visualize it for you. X is in the 0, right? Right in the middle. Can you see 4 and -4? Can you see what the R is telling you? It's saying 4 away from 0 either side. You see, that's what the radius of convergence. It's like a big circle, and it's 4 away and 4 away, right? And if you do complex functions, right, functions and complex numbers, that becomes even more obvious. That's a good way of looking at it. Of course, don't we still have a problem with the endpoints? And up to this point, having all the endpoints ended up failing, right? They weren't usable. But I chose this question because there are some that work. So there are 2 endpoints to test. I'm going to test x equals -4 first. So my series becomes -4 to the n over n to the 4, 4 to the n. And I'm going to do some algebra on this. We don't like numbers inside negatives like that. Are you comfortable with -4 to the n is the same thing as -1 to the n times 4 to the n? Are you comfortable with the algebra that did that? Does it make sense to you? Now, they cancel. So what does this simplify down to? Well, it simplifies down to that guy, doesn't it? Do you recognize what would be an alternating series? Are you experienced enough to realize that that one's going to converge? Are you at the point where you can look at them and you know it's going to happen? So you are going to take that guy and you're just going to say, I can look at it and from experience it converges. And that's what you're going to do for your homework, right? Because you don't want to spend another 20 minutes doing an alternating series. But if you did it in the final, won't you prove that to me using an alternating series test? Now, the other one is x equals 4. And let's see what that generates. Well, x to the n becomes 4 to the n. And on the bottom, you're having n to the 4, 4 to the n. And they cancel, leave a 1 behind. And now, the simplified version is that guy. Do you recognize that fella? Who's he? We have a name for these guys, the ones that look like this one.
E series, right?
Yeah, and isn't p equals 4, so it also converges. You agreed?
Well, 4 is larger than 1, yes.
Yeah. So we now have an updated interval of convergence. You can use x equals -4 and you can use x equals 4. So you see how they're now square brackets, not curved brackets, right? Square brackets mean you can use the numbers on the end. Rounded brackets like we have here, you can't. And the radius convergence would be 4. So these are the two answers that you're going to be doing in your homework, right? Are we good? Any questions so far? So I'll move on. Just randomly picking guys to do. Oh, yes, this is a cool question. I like this question for all sorts of reasons. It's not obvious, but this is 3n factorial, right? If you see the way it's written, you wouldn't necessarily assume that that's the case. If they want you to do 3n factorial, they must put a bracket around. Okay, so if they write 3n factorial, it means that. Okay, so if you see 4n factorial, it means 4 lots of n factorial. It doesn't mean this guy, because this guy and this guy are not the same, right? 3 times 10 factorial is not the same as 30 factorial, right? Trust me, they're miles difference. So let's do the ratio test. If you put, this is messy, but I like it because it is. If you replace this n with n plus 1, would you agree you get n plus 1 plus 3, you get n plus 4? Is it okay for me to do that in one go there and write it down? Now the bottom term is going to be 3, and that guy there is going to be n plus 1 factorial. Now if you do an, which is this guy, but turned upside down, you get 3 times n factorial over x to the n plus 3. Right. There is some obvious cancelling, and then there's some not so obvious cancelling. Anybody want to give me an obvious thing on the top and bottom that you can cancel?
Please.
Yeah, why not? Get rid of them, one of each. What about x to the power of n plus 4 and x to the power of n plus 3? I think that's still pretty obvious cancelling. What would happen if these two had a little battle? What would be left over?
X.
Right. Would you agree it's on the top?
Yep.
In fact, I can't think of a question where it's never on the top, right? It's kind of always going to be in the top, right? Just the map. Now, the less obvious one, but hopefully you've seen a few of these, so it's a little bit more comfortable. Right, that's these two guys, right? They cancel.
1 over n plus 1.
Have you seen enough of them to get comfortable with it? So if we take all the pieces that we've simplified down, let's see what we have. We have an x left. And no. And on the bottom, we have an n plus 1. Right, that's all that was left. Agreed? Everything else get killed off. And this one's a little bit different. I don't think this has happened before. I can now find the limit of this. Now think of x as a fixed number, right? Like 42. What did 42 over n plus 1 get you when n goes infinite? Essentially brute force.
0.
Agreed? Wait a minute. Isn't the ratio test says that the limit needs to be less than 1? Well, isn't 0 definitely less than 1? And do you notice that this one doesn't have any x's, right? No absolute value of x or anything, right? It's just, isn't this essentially true for every x? So that's the easy one. The radius of convergence is infinite, right? Starting at 0 forever. And the interval of convergence is everybody. So in that question, isn't there a lot less work? If it's always going to converge, doesn't that mean all values of x work and r is infinite? That makes sense? 0 is less than 1, it's always going to work. And that's a kind of cool one. Now I'm going hunting for an ugly one if I can find it. If they're not, I'm going to make one. And an ugly one, I'm not sure if that's the best description of it, but it's only one that came into my head.
11.
Has 11 got x plus 1s in it or something? Yeah, we're not doing them yet, but you're right. 11 is ugly for a different reason. Okay, here is one. That's not ugly. The answer is ugly, but that's not. So the limit is n tends to infinity of an plus 1. Is that going to do it? No, that blinking one isn't going to do it. Okay. Can I make this e to the n?
No.
I am. I'm going to pick it as e to the n, right? So it's going to be the limit as n tends to infinity. E to the n plus 1. Darn it, that one's going to work. Okay, I'm trying to find really
Integral
good-
test.
Try number 2.
I don't think 2 is going to be particularly. I'm trying to find one where r is 0. Right, let's think. R is 0. That one isn't going to work because it's going to be 1 over e, and we can live with 1 over e. Okay. When all else fails, use factorials. Yeah. The limit as n tends to infinity of an plus 1 over n becomes the limit as n tends to infinity of n plus 1 x to the n plus 1, right? Factorial. And on the bottom, n factorial x to the n, right? Nothing too scary. Cancelling. Well, those two cancel and leave behind an x. So we're kind of used to that. And I think we just did one like that not that long ago, right? So if you have n plus 1 factorial on the top and n factorial on the bottom, would you agree that you get n plus 1 left over and it's on the top? So this thing simplifies down to n times x. Now, what's that going to look like? Well, if you think of x as a fixed number, won't that be infinity times x? And so won't this limit be infinite? Are we good? I'm seeing a puzzled face there. Are we good, Thomas?
Well, I was just wondering how we got nx. It's because it's n plus 1 times x.
Right, it's x to the n plus 1 and x to the n on the bottom. So the x's cancel and
Down
leave
on the
1x.
left, the factorial.
I'm talking about the factorial, like n plus the expression n plus 1
Oh,
times x.
there we go.
Oh, there we go. Yeah.
Right, n plus 1x. Thankfully, the answer's still infinite, right? And wait a minute, is that ever going to be less than 0? No, right? Infinity is never less than 0. So
Less than one.
what does that look like? Well, r is equal to 0. And technically, there is one value of x that works. And I wouldn't even call it an interval. And the value of x that works is 0, right? Now, if you make x equals 0, right? Won't this be 1 factorial times nothing, plus 2 factorial times nothing, plus 1,000,000 factorial times nothing? Don't you essentially add up a whole load of zeros? So the interval of convergence is in fact just a single value of x, and that value of x is at 0. Are we good? So that power series here is useless. It doesn't work unless x is 0, and when x is 0, isn't the value of it just 0? So you're getting nothing. Nothing of any constructor. All the other ones work for various intervals, but not that one. So let's look at, forgot that one? No, I've done that one, right? When you write a power series like this, you know, I'm just making up one, 2 to the n, x to the n over n factorial. When the guy here is x, we say that this power series is centered at x equals 0. So if you ever see a power series at x to the n plus 1, as long as it's x, with whatever power they throw at you, we say that those are power series centered at 0. We're now going to look at power series that are centered at another number. This power series is centered at x equals 3. Now, can you see why we talk about it centered at 3? Basically, what is the value of x that makes this guy 0? Because isn't this the only one that you're guaranteed to get a solution from, right? So you kind of need to know what the center looks like and where it is. Now, if you make it a little bit more awkward, this is not centered at 5. What's this power series centered at?
5/2.
5/2. So the key is, whatever this is, what value of x makes it 0? And that's where it's centered. And if you're interested, as you'll find out later, but I'll tell you some names. Power series that are centered at 0 are called Maclaurin series. So you might see videos talking about a Maclaurin series. It just means it's a power series that looks like this, centered at 0. And if they're written like this guy or this guy, they are called Taylor's series. So if you have a power series that's centered at a number that's not 0, they're called Taylor's series. And Maclaurin got the Maclaurin series came first. In other words, Maclaurin figured out that functions could be written as power series. And then Taylor expanded his idea to generate these guys. And you might say, well, why do we need, two different centers? Can you imagine that this is a function, right? It's a representation of a function, right? Because all power series represent functions of some kind or other. Can you have a problem evaluating a function at 0? For instance, if I wanted to do the natural log of x, wouldn't it be a bad idea to center it at 0? Because the log of 0 is a bad place. But couldn't I center it at 1 or at 41? In which case I'd be able to represent it, even awkward functions like log x. So that's where that came from. So we are now going to be looking at Taylor series, right? Power series that are not centered at 0. And we are going to find radius and interval of convergence, right? Radius and interval convergence. And we are going to use the ratio test. So in a lot of ways, many of the things are similar. So I'm going to write down, oh, I've just noticed something. I guess I should talk about it right now. Have you noticed that this one starts at 2? N equals 2. Right, you notice that? And you notice this one starts at 1, and this one starts at 1, and this one starts at 1. You can start at 10, you can start at 100, you can start at 0. And as long as you don't cause problems. So why does this one start at 2 and not at 1?
Natural log
Or
of 1 is
0.
0, and 0 on the denominator is a no-go.
A no-go, right? So some power series start at 3, because there's a problem with 1 and 2, right? Or 0, 1 and 2, and that's okay. Does it change anything? Not a darn thing. The radius of convergence and the interval of convergence will be the same, provided you haven't chosen a start value that causes problems, right? So I could say n equals 20 to infinity, and the radius and the interval of convergence would be the same, right? So the limit as n tends to infinity of an plus 1 over an. Not changing that at all. If you make the n's, that's this one, and this one, n plus 1, you get x plus 4 to the n plus 1. You get 4 to the n plus 1, and you get the natural log of n plus 1. You all comfortable with the n plus 1s? Now, when you do the divide by an, don't we basically just take this guy and turn him upside down? So what you're going to have now on the top is a 4 to the n, a natural log of n, and an x plus 4 to the n. Okay. Time for some carnage. Let's kill some things. Tell me something that can kill something else and what's left over.
4 to the n and the 4 to the n plus 1.
And what's left over, where does it go?
4 on the bottom.
Agreed. There's only one more thing that you can cancel. So what can you cancel, and tell me what's left over and where it goes?
Is x plus 4 to the n plus 1 can be written as x plus 4 time another version of it, right?
Yeah.
Without the n. So I would assume that the x plus 4 to the n would cancel out another x plus 4 to the n, leave with x plus 4
Yes.
to the 1.
Yeah, that's what it is. Agreed? Now, I'm putting together all the pieces and I'm going to rearrange them a little bit. I'm putting the log n and the log n plus 1 here. And then I'm leaving the x plus 4 and the 4 separate, right? I'm just separating them. It makes life easy. Aren't these considered numbers, right? These are just constants. So again, in the big scheme of things, you would prove that, but hopefully you can look at that and just tell me what's the limit of this ugly fraction as n goes infinite.
One.
1. And if you want to prove it to me, do L'Hopital, and then do L'Hopital twice, and you're done. It's 1. So this thing ends up being x plus 4 over 4. Are you comfortable with that? 1 times this gets you this. Now, because it's a ratio test, doesn't it have to be less than 1? And I don't want fractions. I maybe not be able to get x, but can't I at least get x plus 4, right? X with some stuff. And that's the format that we need. Now, once you get to this stage, won't this converge, right? It's less than 1, as long as this absolute value is less than 4. So far, so good. So won't the radius of convergence be 4? We're comfortable with that. Don't leave that. Rewrite it by multiplying both sides by 4. Rewrite it like this. And so the radius of convergence is 4. Now we need to know what the interval of convergence is going to be. I'm not sure how long ago you've ever done one of these guys, solved an absolute value equation. So let me show you how it works. If the absolute value of x plus 4 is less than 4, then the absolute value of x plus 4 will be between -4 and 4. Are you comfortable with that step? And what I'm going to do now is subtract 4 from all 3 of these guys. And if I subtract 4 from here, subtract it from the middle, and subtract it from here, do you see that I now have an interval of convergence of -8 to 0? So do you see that the x's are not symmetric? It's not -22 or -44. That's what happens when you centered at 0. But in this case, aren't we centered at -4? Can you see up here? Now, if I draw this guy, it might make a bit of sense. Here is -4. If you go 4 places either side, can you see why that is that? And maybe that's another way of coming up with the interval of convergence. Don't we have to test the endpoints? Right. So let's see what happens here. I'm going to test x is -8. So this thing here is going to have x replaced by -8. And what do we get? We get -8 add 4 to the power of n all over 4 to the n natural log of n. That becomes -4 to the n over 4 to the n natural log of n. We don't like -4 to the power of n. We'll call it -1 to the n, 4 to the n. And when we simplify it down by cancelling these guys, we are now looking at a fella that's actually quite nice. Do you see an alternating series? Anybody want to tell me, does that one converge or not? And you're really doing a kind of guess, because you could do the alternating series test and prove it, right? But we're for homework purposes, we want to take shortcuts, don't we? Does that converge? 50-50 chance. Yes, it converges. No, it doesn't.
Yes.
Yeah.
Is your gut feeling yes? Because your gut feeling's getting better now, right? See, the more of these you do, isn't your gut feeling going to tell you the right answer? Why? Because I've seen guys like that or almost like that, and I remember it converged, that kind of thing. That's what you call experience. I'm not any more intelligent than any of you. Probably I'm dumber than some of you as well. But the reason I can teach you mathematics is I've got more experience than you, right? I've done a lot more math than you. I have done thousands, literally thousands of ratio tests in my life. So can you imagine that I've probably seen a large number of them? I still get caught out, but my gut feeling is pretty good, right? I can look at something and say, yeah, I know it's going to converge. And I also say, yeah, and I know how to prove it. If you gave me money, I choose not to prove them for time issues. So it converges. Well, we still have to test x equals 0. So that's going to be 0 plus 4 to the n, 4 to the n, natural log of n. And that becomes 4 to the n over 4 to the n, natural log of n. We get a nice cancel. And now we are left with that guy. Okay, back to your gut feeling. Do you think that's going to converge or diverge? What do you think about this one?
Diverge.
Agreed. If you had to prove it, do a comparison test to 1 over n. And it's bigger than 1 over n, it diverges, right? So I could prove it as well. Which now means we put the package together. The radius convergence is 4, it always will be 4. The interval of convergence, you can use -8, but you can't use 0. Do you see the square brackets? You can use -8, right, because it converges, but you can't use 0 because at 0 it diverges. In the big scheme of things, the reason why you did 2 weeks of tests was so you could do this, because power series are the cool guys. That's the guys that we like to use, and they appear in all sorts of weird places. There are in fact some functions, look this up, there's a function called the beta function, which actually is described in terms, one of its ways at least, is in terms of a power series. There's an alpha function and there's a gamma function, although the gamma function could be described as an integral as well. So there are some functions out there that are only exist in their power series format. But you don't know them because in your calculator, the calculator has stored the formula for the power series. To give you an example, do you know sine x is a power series? How do you think the calculator knows what the sine of pi over 7 is? I mean, how does it know what that is? I mean, do you think it draws a triangle and kind of tries to build it and measure it? No.
It has a formula for it.
It has a formula for it. And if you say, what is the formula for it? It's a power series. And what they do is that you don't need to do a power series forever. Aren't most of the answers stored in the first 5, 6, 7 terms? So don't you only need to store the first 5, 6, 7 terms, and now you've got a way to get the sine of the, whatever it is, to 4 decimal places. Now, if you want 400 decimal places, don't you just do the power series to 1,000,000 terms, which is horrible for a human, but isn't that very easy for a computer? So things that you are, things that you consider as being functions, and they are. If you really look at them, another way to look at them is that they're just power series. Now, I've only shown you one power series, right? 1 over 1 minus x, but there are many others. In fact, theoretically, everybody is a power series. So where shall I go with the next one? Well, I'm not doing that one because it's actually the same question. That was weird. Let's do this one, 13. Sigma n equals 1 infinity. X minus 4 to the n over n to the n. Now I've chosen this one as a special case. Would you agree that it's centered at 4? Can you tell? Centered at 4. Right. Now, I am not going to do the ratio test. Although 99% of the time I will, but not this time. Can anybody tell me what test I am going to use? 99% of the time, I would use the ratio test. Technically, I could use the ratio test on this, but it would be really ugly.
What about the root test? Because it
No.
had the same n root that's shared on both top and bottom.
Agreed. Now let's see what happens. It becomes a limit as n tends to infinity. You agree when you take out the nth, you get an x minus 4 on the top. We'll bracket around it, I guess. Over n. Wasn't that much nicer than the ratio test, mathematically? Now, what do we know about this guy? Well, if you make n infinite, doesn't the answer to this become 0? Right? Isn't the limit of x minus 4 over n 0? Great. A number divided by infinite, right? 0. And that is less than 1. So what is my, I almost gave the answer there. What is the radius of convergence if a series always converges, as it will here, because the limit is 0 and 0 is less than 1, so it will converge no matter what x is. What's the radius of convergence?
Infinity.
Infinity. And what is the interval of convergence going to be?
The infinity to infinity.
Yeah. And you see, in this case, you don't really have a lot of work to do. Isn't that a nice question? The root test worked better than the ratio test. Now, you could do the ratio test, you could. Can you trust me? It's really ugly and you don't want to do it, right?
Can
But
you
you could.
demonstrate?
I'll start it for you, but I'm not going to do any more. It would be x minus 4 to the n plus 1 over n plus 1 to the power of n plus 1. Upside down, you've got x to the n over x minus 4 to the n. If you cancel these guys, you get your x minus 4. If you take these two guys and you rewrite them as n to the n over n plus 1 to the n with an extra n plus 1 on the bottom, you get that. Now, there's a bit of work to do with n to the n over n plus 1 to the n. Can you remember that guy ends up being a version of e eventually? But isn't that guy e over n plus 1? And won't e over n plus 1 get you 0 and you're back to here and you're back to the same answer? But you would have to do a fair amount of algebra to prove that the limit of that is 1, right? You'd have to, combine it into a single fraction and turn it upside down. It ends up being e to the negative 1, but times 0, essentially. So it dies. Cool?
Yep.
Right. I've got time for 2 more questions. Here is 14, which is going to be a really quick question. Right. And I'm back to using the ratio test. So n plus 1 factorial, 3x take away 1 to the power of, n plus 1, that's the top. And then an n factorial and a 3x minus 1 to the n on the bottom. Where is this power series centered? This is the Taylor series. Where is it centered?
1/3, right?
Agreed. You agree it's centered at a third. Right, that's going to be important later. Now, n plus 1 factorial cancels n factorial, but we're becoming experienced at that. So don't you get an n plus 1 left on the top? And 3x minus 1 to the n cancels out most of that, but you're left with a 3x minus 1 left over. So your simplified limit is now n plus 1 times 3x minus 1, right? It's that guy. Now, in this case, won't you get infinity times that? And so you will get infinity. And infinity is never going to be less than 1. So that means the radius of convergence is 0. Right? If it's never going to work, except for one special case, the radius is 0. But the interval of convergence does have one value of x that works. In the one we did earlier today, wasn't the value of x 0? But what is the value of x where this theoretically will still converge? And there's only one value of x.
1/3.
Third.
Is 1/3. So you see that that is only when x is a third do you end up adding a whole load of zeros, right? And that's kind of trivial. And in this question, they actually give you a list of choices for I, rather than you writing it down, which is fine. Our last question, let's see if I can scroll by it. No, I'm wrong. I thought I had one more. Where are you? Have I been going really fast today? I probably have, because I didn't think we'd be finished today. That's why I said we'll continue it on Thursday.
Number 2.
Is question 2 got an issue?
Well, it's got S cube root.
Okay, let's do that one. So after this one, all the other questions are watch a video and answer it. And I think those ones you should do on your own. So last question for today, which means that when you come back on Thursday, we can actually start a new section. And that's fine. It means you have more time in the future. Ooh, interesting question. I'm going to rewrite it. As n to the 1/5, right? 5th root is a fractional pair. So the limit as n tends to infinity, ratio test.
Just a question. Is negative
Mhm.
1 to the nth root?
Missed my n.
All right.
Is that what you're asking? Yeah, I missed my n. So it's going to be the limit as n tends to infinity. Okay, if you put n plus 1 here, n plus 1 here, and on the bottom, n plus 1 to the 5th. And now if you turn this guy upside down with the n versions, you get that. Nothing too serious yet. Okay. Can we just kill off all the negative ones as you always do? Right, they're just going to become ones, right? Because the absolute value kills them. Would you also agree that we can do these guys and leave with an x on the top, right? So we are looking the limit as n tends to infinity of n to the 1/5 over n plus 1 to the 1/5 and an x. So this is the guy that's going to cause us trouble. I know the answer is 1. You might be able to look at it and realize that it's 1. Right?
Can I propose a solution?
Go for it, yeah. I'd like to hear your thoughts.
So it share the power 1/5, right?
Correct.
So you remember there's a power property where let's see, so AB over the power of C could be equal to AC over power of BC, right?
Yeah, essentially that. Okay, good start. Where are you off to now?
We go with
Brute
the usual
force.
part.
Not yet, because you're going to have infinity over infinity. Brute force is coming, but not quite yet.
First off, we gotta divide the both top and bottom of that ugly function by an n.
Okay.
For the L'Hopital rule, if anyone prefer it.
No, nobody prefers it, not with that fraction. I don't. So I'm going to divide the inside, top and bottom, by 1 over n, which I'm allowed to do, actually. Right. Can we do the brute force now? Okay. So what you're going to get, 1 over 1 plus 1 over infinity to the power of a fifth times x. Right, isn't that 0? And 1 plus 0 is 1, and 1 over 1 is 1. And isn't 1 to the power of a fifth still 1? So the bottom line is, it's 1 times the absolute value of x. And it's only going to converge when that limit is less than 1. And in this case then, won't r be 1? And the interval of convergence will be -1 to 1. And then you would test the 2 endpoints. I should be able to do that in my head. If you plug the first one in, it fails. But if you plug in the second one, it's an alternating series. So the interval of convergence, can't use -1, but you can use 1. I just did that in my head, but you could check it out. Are we good? Right, hopefully you have time. I'm going to be doing your first report. It should be ready. It will be ready because that's what I'm going to make sure happens. It will be ready before I see you on Thursday. Okay, so it will have your 2 test scores. It will have your homework, your participation grade, and what your overall grade is right now, up to the end of week 2. Right, so that's where it is. And give you an idea of how you're doing. Okay, if you last name for attendance, and we're out of here. I'll hang about for any questions.
Bring me my brown pets.
What will you say?
Bring me my brown pets.
Either my hearing's going. All I'm hearing is pets at the end.
Bring me my brown pants.
Oh, he's telling us the punchline to a really bad joke about guy out at sea fighting. So if you don't know the joke, it's bring me my brown pants is the punchline. Kira, have you got a question, or are you just hanging about because you can?
Just hanging about.
In case someone else has got one and it's helpful, right? Has anybody got a question so that the others can hear it?
I don't have a question. But thank you for class. Good seeing
Thank you. Yeah.
See you.
Well, when you see my boss, will you tell him to give me a raise?
Oh yeah, if I see him.
Okay. And when
Take
you
care.
tell my wife, will you tell her that my jokes are really good because she doesn't believe me?
Yeah.
Is that pushing it? Yeah, it's probably pushing it. Right. Has anybody got a math-related joke? Or a
I
math?
have a math-related joke.
You've got what, Thomas?
A math-related joke.
Go for it.
There's some engineers that were trying to measure the height of a pole, but they didn't have any ladder. They're just standing around trying to come up with an idea. And a mathematician walks up to them and says, "What are you trying to do?" They said, "We're trying to measure the height of the pole, but we don't have any ladder." So the mathematician takes the pole out of the ground, lays it on the ground, and measures it from there. He gives them the measurement and walks off. And one of the engineers says, "Look at that mathematician. We asked for the height, he gave us the width."
I'm having a bad effect on people because I think my bad jokes are, oh God, that is painful. It's kind of funny, but it is painful. What about you, Kira? Do you have a joke?
Sadly, no.
Oh. So I'm just curious if we're chatting until someone gives me a math question.
I have a math question then.
Okay, go for it.
So on test 2,
Okay.
I missed pretty much the last question.
Okay, let me find it. 163, we're here. Score, Thomas will check yours because it'll have your numbers on it.
Mm-hmm.
Well, it's probably the only question you missed.
That was part of the question 11 also.
Oh, you're right. A little bit of 11, but it was mostly 12 that the problem happened. Agreed?
Yeah.
Okay, let's look at question 12 and see what's going on here. So I'll switch over to the main screen. I'll show you the kind of the process I'd be using. Okay, so you're looking at essentially this series, which is an alternating series, right?
Mm-hmm.
And the error that you're being asked to calculate is 0.00005. So that would be just another way of saying, give me the answer to 4 decimal places.
Yeah.
Right, now the first part is it's an alternating series and it converges, which you can certainly prove, and it's not that hard to do. Now, it says select all the following that apply. And the first one, it says, is that guy is greater than that guy. Okay,
Mm-hmm.
and you said, I believe, yes, that's true.
I think I said
That-
yes for the first 3 ones.
Yeah, so that one is not in fact true. Pick a number like 100, right?
Mhm.
Just actually pick a number like 2, easy to calculate. 1 over 3 to the power of 5 is not bigger than 1 over 2 to the power of 5. Why? If that number is bigger,
yeah.
right? So that was that one wrong. Now, I'm coming back to a weird result, but that's fine. Of course, that way around is true. And that one is the one you should have checked.
Did I check it?
No.
Hmm.
And you did pick the 1 over n to the 5 guy is equal to 0. And that one is correct. So you check that. And it says here, which conditions below show that it converges. So it is true that the limit of that is 0, but that is not one of the conditions. For an alternating series, this one to converge, shouldn't it be decreasing, which is basically what that is saying?
Yeah.
And shouldn't its limit be 0, which is essentially what that is saying? So these are the only 2 that you should have chosen.
So that was the.
That
1
would be
over-
the 3rd and the 4th one.
All right.
Now, there is a little disagreement. You said 8 and they said 7.
Well, I picked.
I don't know. Yeah.
I picked 8 because it seemed like I've been having a little bit of trouble with WebAssign on
Okay.
because I would go a little farther.
Well, if we were looking at what we need to do here, aren't we trying to find,
Mm-hmm. So yeah.
essentially we're trying to find an plus 1, right? And then take away 1, right? Or the other way of looking at it is we want to find an and subtract 1, which is how I would do it. So if you take this guy here.
Did you do that
And-
into the 5th?
Yeah, into the
Okay.
5th.
Yeah. I did that.
So you're going to do this guy here. And so n is just going to be the 5th root of that guy, which I'm about to do. So brackets 1 divided by 0.00005. And I get that number. Right. And then I'll take that answer, and raise it to the power of 1/5. And the answer that we get here is essentially 7. Oh, right. Now, there's two things going on here, and I think I know what's going to happen. Shouldn't you make n equals 8?
Yeah, so that's what I did.
Right. But when n is equal to 8, you're really saying that guy is 8. So that makes this guy 7.
All right.
You need 7 terms to make this 8. I know it's kind of weird, but that's kind of what it happens. So that's all it was. You were in the right ballpark.
It's a little confusing still.
It is. So here's basically another way of tackling it. Find out the value of n that solves that. And if you find the value of n that solves that, you will find out that it's 7. Because the error is the en plus 1th term.
All right.
Right,
So I was
so-
looking for the error.
Right, so if you take that guy, you are looking at solving when is this guy equal to the error, which means essentially the same calculation. And n now does represent how many terms you need to get your accuracy. So it's going to be that ugly guy, take away 1. Now we already know what that ugly guy is equal to. He's 7.24, take away 1. That gets you 6.24. And you don't have decimals. You always round up. So there's where the 7 came from.
So this was looking, how many terms do I need in order to get the error to that?
Yeah. So if you wanted to get this accuracy, you would have to do the original function. That's this guy here
Yeah.
from 1 to 7. Basically S7. It's called the partial sum.
All right. And was that the same thing that happened on 11 when I was calculating the error?
Yeah. Same thing. If you picked 2, you would have been right.
All right.
So I think for your benefit, because you know there's two things happening, won't you essentially always solve this guy? What value of n makes that equal to whatever the error happens to be?
Okay, so when I'm using error, I use a of n plus 1.
Right, so use a of n plus 1. And if you
Alright.
solve that guy, the n that you get, whatever it is the one that you're going to use. You won't need to add or subtract anything to it. And that might make it a little bit easier for you.
Okay, I think I didn't catch on to that.
Right.
But okay, I think that makes sense now.
Okay. Have we any other questions?
I have one about my homework. I'm the person that was emailing you all week about my messed up account and asking for extensions on the homework and stuff.
Yes.
I know that I can't do the test, but I think there was 3 things of homework last week, and you only extended the 2.
Oh, that's just a mistake. Let me fix that. Let me double check, Jessica. Okay, 163. Let's go into score view. And useless piece of information for you, but do you know that your last name is my mum's maiden name?
Oh, really?
Yeah.
That's nice.
Yeah.
I like that. I don't
So,
know.
so there are 3 you're saying. So I'm assuming that the one I've forgotten, yep, you're right, I've forgotten it. I will now extend it, is the alternating series one.
Yeah, perfect. Okay.
One more question.
Okay, that's done.
Thank you.
You're
Appreciate it.
welcome. Right, what you got for me, Thomas?
So I was doing homework from section 11.6,
Uh-huh.
and I think
Right.
I ran into the same problem. I'm thinking this is the same
Part
problem.
of the same issue. Okay, so let's tackle it a different way. Which question was that again?
17.
In 11.5?
6.
Oh, that's ratio test. Wait, that's different then.
Yeah.
Yeah. Wait, yeah.
What was I supposed to be using?
Well, if it's error, they give you a formula that you should be using.
Yes, I was using their formula. and-
Okay, so that's where we need to go then. So what in the heck is going on here? Okay, that has to be upped to 100 points or some reason. I didn't do that. That's not the issue. Right, question 17. Let's do that one then.
Is the homework worth less than it's supposed to be?
No, yes, but I can fix it. All I do is
Yeah.
regrade it, and it does it automatically. So your number's a bit out. So let me have a look at what we have got in question 17. So in question 17, you've got your series,
Mhm.
which is 5 n times 2 to the n. Okay, and it starts at 1 and finishes at infinity. And the error that you're going to calculate is called a R5. And to get R5, the formula is en plus 1 over 1 take away the limit as n tends to infinity of an plus 1 over an. Now, this here is the limit that you used when you calculated this guy, if you did, to check that it converged.
So I checked a conversion. It came to 1/2.
Okay, perfect. So
Well, you check that?
No.
Maybe okay.
So what we are looking at here is R5. So R5 means A6, right? Because if that's 5, this is one more. 1 takeaway, and we'll assume that that's a half, which seems reasonable. Now, what's A6 going to be? Well, 5 over 6 times 2 to the 6.
Mhm.
Right? That's what you get when you plug in 6 here. So it's going to be 5 over 6 times 2 to the power of 6. That's the top. And 1 takeaway a half is a half on the bottom. And I'll now do the calculation. It's really ugly. And so I'm going to do 5 divided by, put a bracket around it, 6 times 2 to the power of 6, close the bracket off. And that's the top bit. And divided by half is like
Okay,
multiplying
I think
by.
I see where I went wrong.
And there you go. And that is the correct answer.
Right there.
Yeah,
You-
0.02604, whatever accuracy they want.
And then what about the n number of terms?
Right. Well, the number of terms that you're going to use here is part B. Okay. Okay.
Mhm.
Using the formula for part B, from part B. Using the formula from part B. How can you use a formula from part B when that is called part B? I think they mean use this formula, right? Find the maximum value of n so that n, well, don't we already know at least how we're going to do this one? Rn is going to be a to the n plus 1 over 1 take away a half, because that's always going to be a half.
Mhm.
And so that's going to be en plus 1 over a half, which is going to be 2 en plus 1s. I'm just tidying that up before I do calculations. Now, what does en plus 1 look like? It's 5 n plus 1, 2 to the n plus 1. Done. So that is this guy with n plus 1 instead of an n. And we need this to be equal to 0.00005. So when we solve this, we're going to get n is 2, or n is 12, or n is 49, right? But we
Mhm.
still have to solve that. And that is not going to be done algebraically. I'm not even going to attempt to do that algebraically. What I would do is I'd go to Desmos. So I'm
So
going to
yeah, that's what I did.
Right, so bear with me. I'll check that out right now. Because maybe it's just there that the issue
Mhm.
happened. So I'm going to switch over. Okay, I've lost my darn stupid Windows. Go away. And here we go. So I'm going to go to the Desmos and I'm going to type in two functions. And the first one is essentially that expression that we calculated. So it's 2 and a bracket. And inside that bracket, there was a 5 on the top. And on the bottom, there's an n plus 1, which I'm going to call x plus 1. And a 2 to the power of, ooh, I hope I can write this in, x plus 1. No, so I'm going to have to go
Use
and make
brackets?
that a little brackety thing there. Yeah. So are you comfortable? That's essentially the,
Mhm.
right. Now on the other part of this, I'm going to put in essentially just y equals, and I have to go back to that because I forgot y equals the error. And this guy, I'm going to put y equals. And then I'm going to go over here and I'm going to adjust the y values. Since I'm interested in 0.0005, I'm going to make this guy 0.000, 4 zeros, 4 zeros and a 6. And I'm going to make this guy just 0. So hopefully when I click out of this, I should be able to get, no, what happened to my y values? Did I change them? Oh, no. Okay.
Oh, you
So,
forgot to change the other side.
okay. So I'm going to make this guy 0. And I'll make this side all the 0.005s. And I have to make it one more just so I can see it.
Yeah.
And now if I zoom out, there's my guy. And that guy looks like 13.
You got 13?
Yeah. 12.821. Does that look like 13 to you when you round it up?
Yeah.
Now,